Hey guys, today we'll be talking about forces in one dimension. Now, first of all, let me just write the heading: forces in one dimension. Now, what do you mean by one dimension? We have already seen that if you remember, whenever we make a graph, there's always a y-axis and there's always an x-axis. We call the y-axis as the first dimension and the x-axis is the second dimension. So whatever we are making, it's in two dimensions because it involves both the y-axis and the x-axis. However, when we are talking about 1D, it only involves forces that are in one direction. Let's say the forces can be vertical in this case. Forces can be vertical, going upwards probably and going downwards. Or the forces can be horizontal, going to the right, for example, or going to the left. Now remember, force is a vector quantity, so the direction is of vital importance. The direction is very important, and this is one of the major concepts of forces. So it can be in a vertical direction or in a horizontal direction, but not in both. In this chapter, in this concept, we'll not be talking about forces that are, let's say, in this direction, because this would involve something in x and in y. So right now, when we're talking about forces in one dimension, we'll only be talking about forces that are either purely vertical, or purely horizontal. So these are forces in one direction, in one dimension. Let's see. Let's take an example. We already know Newton's second law, which says F is equals to ma. Force is equals to mass times acceleration. If you do not remember this, then kindly review the videos earlier and you would get to see that we found out this formula here, the second law of motion. So we know this. Now, for example, there is a body, there is a mass here, and I am pulling it with a force of, let's say, 20 newtons. However, there is one other person who is pulling this mass on the other side with a force of, let's say, 40 newtons. Now just imagine a situation. Two guys are pulling a mass in the opposite directions. So now, if you just think about this logically, obviously the one with greater force would take it. It would move in this direction. I can say that. That is not the point here. Now we would have to see by how much force is this mass going to move in that direction. So since these forces are in opposite direction, so we should always, first of all, make our reference axis. This is our reference axis. A reference axis tells you which direction you are considering positive, and you can choose either direction as positive, but that direction should be consistent. Let's say in this example, I am saying that a force in that is pointing in the right on the right is positive. However, a force that is pointing on the left is negative. Now this is totally arbitrary, or this is my choice completely. This is what I mean by arbitrary. This is my choice. So I could have taken this one as positive and this one as negative. So it's the same thing. As long as I follow this this reference axis, the answers are going to be same. So whenever I will have a negative answer, it would mean that the force is in the negative direction. And whenever I would have a positive answer, it would mean that the force is moving on the right hand side, or the object has a force which is on the right hand side. So let's see. Now we have to find the magnitude of the force. We know that the force going on the left hand side is a negative force because we have just fixed this for this example. So this is, we'll take this as minus 40. And the force going on the right hand side is a positive force. So to find the magnitude, we're just simply adding the two forces, but keeping their directions in mind. This is a minus 40 since it's going on the left hand side, and this is a positive 20. The answer would simply be minus 20 newtons. A minus 20 newtons would tell you that the force is in the left hand side since it has a minus sign. This would tell you that the force is on the left hand side with a magnitude of 20 newtons. So I can say that the final force as a result, as the total force, is 20 newtons in this direction. So we knew this already, that we predicted this, that the direction of the total force would be somewhere in this direction, but now we know the magnitude. Remember, this thing is called the resultant force or the net force or the total force. This is the total force, and your formula, that the F is equals to ma. Here the F stands for not only force, it stands for the net force or the resultant force. So this is the situation. Let's see, let's just take a very simple example. This addition and subtraction is very simple. Let's just say we have a mass of 10 kilograms here, okay, and we have a force here which is 20 newtons. Another force, two people pulling here, this is 40 newtons, and let's say this force here, this is 50 newtons. Alright, now I want to find out the acceleration if all of these forces act on this mass. So first of all, my formula is F is equals to ma. However, the F here stands for total force. For this, I would have to calculate the total force. Now let's see. We'll have to make an arbitrary axis here. Let's say this right hand side on the x-axis, since all the forces are horizontal, purely horizontal, so the right hand side on the x-axis says positive and the left hand side says negative. Now simply add up to find the total force. Simply add up all of the forces. This is on the right hand side, so this would be a plus 20, this would be a plus 40. However, since this is on the left hand side, this would be a minus 15. So this would become 20 plus 40, 60, 60 minus 15 is 45 newtons with a plus sign, which means the net force acting on this box, or the total force acting on this box, is in this direction with a magnitude of 45 newtons. So this is my force. Now since I know the net force, the formula is F net, as in force net, is equals to mass times acceleration. I wanted to find out the acceleration, so F net, just switch the formula, divided by m. Here it was multiplying, it came here and it got divided, is equals to a. F net is 45, mass is 10, and we are finding the acceleration. The acceleration is 45 times divided by 10, which is 4.5 meters per second square. So this is the acceleration. Remember, the direction of the net force tells you the direction of the acceleration. If the direction of the net force is in this direction, this means the acceleration is in this direction. So whatever the direction of the net force is, the direction of acceleration is the same. This means it's increasing its speed in this direction. So this is what it means. Okay. Now let's see another situation here. Let's say we have a box in this direction, a mass of 15 kilograms, and a force of 20 newtons in this direction, force of 15 newtons in this direction. Alright, and we know that there is a force here of 30 newtons. Let's say first of all I need to find out the acceleration wherever the acceleration is. So let's see, first of all the formula is F net is equals to ma. Now for F net we have to find the sum. For this we need to make an arbitrary axis. Since this time all the forces are in y direction, purely vertical, let's say the upwards is positive and downwards is negative. Alright, this is positive and this is negative. So you can do it very well in the opposite direction as well. You can just say that the downward is positive and upward is negative. That would be fine, but you have to be consistent with that arbitrary axis that you have made. So here, just the sum of the forces give you this in the upward direction plus 30, this would be plus 20, this would be minus 15. So this would give me 30 plus 20 minus 15. So this would be 50 minus 15 is 35 newtons. Now the formula is F net is equals to ma. F net divided by m is equals to a. 35 divided by 15 would give you, if you just use your calculator, so this would give you 2.3333 repeating. 2.33 repeating meters per second square. So this is your acceleration. Now let's just find out the direction of acceleration. The box will be accelerating in this direction. Since the resultant force, the F net, was a positive and the resultant force was in this direction, so the acceleration will also be in the direction of the resultant force. So the box will be accelerating in this direction. So I hope this is clear to you. This is a very easy concept. Just kindly review this, and we'll be doing some examples of this so that you have a clear understanding. So thanks for watching, guys.